Okay, let's just dive right in. We are going to tackle a massive, and I mean massive, problem that so many businesses face. How do you get your most critical data out of all those scattered SharePoint files and into a structured SQL database where you can actually, use it? Well, in this explainer, we're building the exact blueprint for a high-performance data pipeline to do just that.
I mean, really think about it for a second. Your sales reports, inventory logs, all those project updates. So much of your most valuable, actionable data isn't sitting in a pretty dashboard. Nope, it's trapped, locked away inside Excel sheets and CSVs, just sitting there on a SharePoint site. This whole explainer is about setting that data free.
And here it is, the big picture, the game plan. It's a simple three-stage journey. We start with the raw documents in SharePoint, then they flow through a powerful N8N workflow. That's what's going to do all the heavy lifting for us. And finally, the data lands clean and ready in your SQL database. So, over the next few minutes, we're going to unpack this exact architecture piece by piece.
But first things first, before a single byte of data can move anywhere, we have to build secure, authenticated bridges. This is the absolute foundation of our entire pipeline. It's all about connecting our N8N workflow to both SharePoint and our SQL database in a way that's totally secure.
So our entry point into the world of SharePoint is something called an Azure AD app registration. The easiest way to think about this, it's like giving your NN workflow its very own official passport to get into the Microsoft ecosystem. This whole process gives you three crucial pieces of information: a client ID, a client secret, and a tenant ID. These are the keys you're going to use in NN to set up a super secure OAuth 2 connection.
Now that passport needs the right visa stamps, right? This is where permissions come in. And what's cool here is how simple it is. If you just need to read files, all sites.read is the bare minimum you'll need. But if your workflow is going to get a little more advanced, like, say, moving a file to an archive folder after it's been processed, then you'll need to grant it the more powerful files.readwrite.all permission.
And here is a pro tip that, trust me, will save you hours of banging your head against the wall. After you set those permissions in Azure, you have to click the Grant Admin Consent button. It's such a small step, but it is hands down the #1 reason server-side automations like this fail. That one click is what officially says, yep, I approve these permissions for my workflow. Don't forget it.
Okay, we are securely connected. We are in. Now it's time to build the data conveyor belt. This is the part of the workflow that's going to find the right files in SharePoint and then feed them in one by one for processing.
And the absolute heart of this conveyor belt is the loop over items node. Look, trying to process 100 files all at once is just a recipe for disaster. You'll run out of memory, things will time out, it'll be a mess. Instead, this node lets us be smart about it. It processes everything sequentially. It grabs one file, runs it through the entire process from start to finish, and only then does it grab the next one. This is absolutely essential for building a stable, robust workflow.
So what's the crucial point? It's this number right here, 1. You have to set the batch size in that loop node to 1. That is the magic number. It's what forces that one-by-one sequential processing we just talked about. This is the architectural key to handling large files and making sure that if one file has an error, it won't crash the entire system.
All right, our files are moving down the conveyor belt. The next stop is the quality control station. This is where we take the raw, messy data from inside those files and we transform it into a perfectly clean, standardized format that our database will accept without a single complaint.
And the tool for this job is the modern Extract from File node. There's an older spreadsheet file node, but it's deprecated, so you definitely want to avoid that. This new node is the way to go, and what's great is that it can handle both CSVs and Excel files, which makes your workflow incredibly versatile.
And you can see here just how simple the configuration is. For a CSV file, you just make sure the header row option is turned on so it knows to use your column names. For an Excel file, you just have to tell it which sheet name to read from. That's it. And in both cases, the output is a beautiful, clean array of JSON objects, ready for the next step.
But hold on. Before we send that data off to our SQL database, we have to run a few critical cleaning operations. This is like a pre-flight check. We have to make sure our field names match our database columns, we got to standardize our date formats, and, this is a big one, we have to handle things like empty strings and single quotes, which are notorious for causing SQL insertion errors.
And I really want to double down on this point because it's a huge gotcha.
To a database, especially something like MS SQL, an empty string is not the same as a null value. If you try to insert an empty string into a number or a date column, your workflow is going to crash. Hard. So you have to transform those empty strings into a proper null value first.
All right, our data is clean, it's structured, and it is ready to go. Now for the most satisfying part of this whole process, loading thousands and thousands of rows into our SQL database at lightning speed. We are about to open the floodgates, but we're going to do it intelligently so we don't create a massive bottleneck.
So that really begs the question, right? How do you actually do this efficiently? I mean, if you have a single file with, say, 10,000 rows of data, are you really going to make 10,000 separate phone calls to your database?
No way. Absolutely not. That's the slow way, and it just creates a massive amount of latency. The smart way, the high-performance way, is to bundle all of those rows into a single large query and make just one database call for everything. The performance difference here isn't just small, it's night and day.
And here's the two-step magic trick to pull this off. First, you use a code node. In there, a little bit of JavaScript loops through your data and formats it into one giant SQL values string. Then you just pass that single string into an SQL node using the execute query operation. One query, one network call, all your data inserted. It's unbelievably fast and efficient.
Okay, we've built the core pipeline. It's fast, it's efficient. But to make this a truly enterprise-grade solution that you can rely on, we need to talk about reliability. How do we handle errors and make sure this automation just keeps running smoothly day after day?
It's actually pretty straightforward. You'll want to use the dedicated error outputs on your key nodes. So if a file fails to download or extract, that error branch should immediately fire off a notification to Slack or an email. And critically, that notification has to include the name of the file that failed and the specific error message. That way, an engineer knows exactly what broke and where to look.
So let's recap the 3 golden rules, the crucial architectural takeaways from this whole explainer. Number 1, sequential processing is mandatory for a robust system. Use that loop node with a batch size of 1. Number 2, data transformation is non-negotiable. Use a code node to proactively clean your data before it ever hits the database. And number 3, bulk insertion is the absolute key to performance. Use a code node to build a single query for maximum speed.
And there you have it. You now have the complete blueprint for turning that SharePoint chaos into SQL clarity. So the real question is, with this powerful architectural pattern in your toolkit, what mission-critical process are you going to automate next?